I'll use two different colors. So HFR is strS, eryS, eryR plus, met plus, gal minus, lac minus, lys minus, and then F minus, strR, eryR, arg minus, met minus, gal plus, lac plus, lys plus. So I didn't say anything new yet. All I did is write down what we know and what we were given in the problem. So this is what we're given, and we're shown how the genes are mapped. So the first thing to remember is that this arrow is pointing the way that HFR is going to give the DNA first. So we're going to actually first inherit gal, then met, lac, lys, strR. So we're actually going this direction. And the key thing to remember here then is that we're going to receive gal the most, then we're going to decrease all the way to the end. So arginine is going to be the last gene that we inherit. And remember, it's always HFR to F minus. F minus is not going to give any DNA, it's only going to receive the DNA. Okay? And so what we need to do here is figure out what we should put in the media in order to allow for the most Exconjugates to be on the plate. So our question of interest is, what should we put in for most Exconjugates? And recall that an Exconjugate just means that's an F minus who has received DNA from HFR and has had time to recombine. So if it received gal, and met from HFR, then it would have time to switch out its gal plus for HFR's gal minus, switch out its eryR for HFR's S, and then switch out its met minus for met plus. So that's what we're saying Exconjugates are. It's the F minus that has received DNA from HFR and it has had time to recombine. And the question is, what can we do to allow for the most Exconjugates? So when a question is asking this is actually a two-step part. Two. So the first thing is we have to be able to kill HFR and F minus because we only want Exconjugates on the plate. So we need to find a way to kill HFR, and we also have to find a way to kill F minus. Once we kill them, then what we're going to do is select for the most Exconjugates. So there's many ways to solve it. This is the way that I like to solve it. So now let's just go through and see all the different ways that we could kill HFR. And I'm going to write each way that we can kill HFR just in parentheses off to the side. So looking at antibiotics specifically, antibiotics are these. And actually let's just go through what the rest are as well, because it's important to distinguish what the different functions are. So we have arginine, methionine, and lysine. So I'm going to go like this. So these are our amino acids. And then gal and lac are alternative sugars. So these ones. And the reason this is important to distinguish what each of these are corresponding to is because if you are sensitive to an antibiotic, that means you'll die if it's on the plate. If you're resistant, that means you will survive. You're resistant to that antibiotic. With amino acids, you need to have all of these amino acids in order to survive. So you need arginine, you need methionine, and you need lysine. So if you have a minus, the only way you can survive is if it's supplemented in the media. If you have pluses, that means you can make it on your own. Think about the pathways that we did in worksheet 5. And you need all of the amino acids that the question is asking about in order to live. And then conversely, when we're talking about sugars, the carbon source that the bacteria need, all of them will always be able to use glucose. But then if you can use an alternative sugar, either galactose or lactose, that means you don't necessarily need glucose. So if you have gal plus or lac plus, that means you can use either one of those sugars instead of glucose. But if you have gal minus or lac minus, that means that you're using glucose for your carbon source. So if you have gal minus and you give a plate with galactose, if you're gal minus and you provide galactose as the only sugar, that means the colonies will not survive because they don't have galactase, the plus, the enzyme, in order to use that as the sugar. Okay, so we just went through the 3 different components to this, and we're doing that because we need to find the ways that we can kill each one of these bacteria. So let's first start with antibiotics for HFR. How can we kill HFR in terms of antibiotics? So they're sensitive to both antibiotics. So that means if we put either STR or eryR on the plate, HFR is going to die. Either one of those ways. So if we want to kill it with antibiotics, we'll use these. We aren't making any decisions yet about what we're actually putting on the media, but right now this is allowing us to go through all the scenarios that we can use to kill things. So strS, eryS, we can plate either one of those and kill HFR. In terms of amino acids, we have arginine, methionine, and lysine. So HFR has pluses for arginine and methionine, which means it can make those on its own, and it needs lys supplemented. So if we don't plate lysine, then it will die because it doesn't have the ability to make it on its own. Okay, and finally, if we go to sugars, it can't use gal and it can't use lactose. So if we're going to give it a sugar, it better be glucose if we want it to live. So if we're going to kill it, then don't give it glucose and use only the other sugars. Okay? So these are 4, well, if you consider this in like another couple ways, there are different ways to kill HFR. And now what we're going to do is not choose one yet, but do the same thing for F minus. So in terms of our antibiotics, what can kill F minus? Neither, because it's resistant to both. So we're not going to write anything down in terms of antibiotics. If we go to the amino acids, what can kill F minus? So it's arg minus, met minus, lys plus. So that's telling us it can't make arginine and it can't make methionine on its own, but it can make lysine. So if we exclude arginine or we exclude methionine, it will die because it can't make it. But lysine, it can make it so it doesn't matter. Now let's go to sugars. There's a plus for both of them in F minus, which means it can use galactose or lactose and then glucose, so we can't kill it in regards to the sugar. The only way to kill F minus is to not plate arginine and not plate methionine. Okay, so we just found all of the ways that we could use to kill the original type of bacteria, because the only thing we want is our Exconjugates. That's the only thing we want to select for. So now we have to go to the circle. The circle is telling us the order at which genes are being inherited. So gal is the first one that HFR is going to give to F minus, and then we go all the way over to arginine, and this is the last one. Arginine is the last one, so that means it's the least likely to be transferred over to F minus. And if that's the case, we expect arginine to have the genotype that's most similar to F minus. So the X conjugate most similar to F minus. Therefore, we look at what F minus is in regards to arginine. Arg minus. And the reason I'm saying that is because it's the last gene to be inherited, and because it's the last one, that means it's less likely to be inherited, because you have to break the pathway at some point. When those pili get broken, you just stop inheriting at some point along the circle, and it's always going to be in this order. So if that's the case, we have less of a chance to have HFR's arginine come in and recombine with the F minus's arginine. So that's the least likely one to happen. Whereas if we look at gal is the one that's transferred the most often. So that means we have the most chance for our X conjugate to have either HFR or F minus's genotype with regards to gal. And we're not saying that all of them are going to be HFR, whatever HFR is, which is gal minus. We're not saying that all of the X conjugates are going to be gal minus, because what we're saying is that all of the X conjugates are going to have inherited this first piece of DNA or whatever, and that means they have the chance to recombine HFR's gal minus with F minus's gal plus. So they could be either plus or minus, the X conjugates. And that's the key piece, that you have to understand which genes are the least likely to be inherited, and then how that corresponds to what the X conjugate genotype is going to be. So the way that I like to work from this is backwards. I start with the one that is the least inherited. So I start here, and then I work down the circle this way. So we started here. Arginine, we said X conjugate is going to be most similar to F minus. So that's telling us that most of our X conjugates are going to be arg minus. And if they're arg minus, that means we need to supplement arginine. Okay? Because they can't make it on their own, it's a minus. They have to have it supplied in the media in order to live. So if we want the X conjugates to live, we better give them arginine, because almost all of them are going to be arg minus, because this last piece to inherit wasn't transferred over from HFR, so it's going to keep the F minus genotype. So we need to put arg minus in the media. So over here, I'll just keep a running list of what we're putting in the media. So we said we need to add arginine. Okay. So now we made a decision. What I like to do, as soon as I choose what to do with one gene, I go to my list and I figure out, sorry, wrong list. I go to this list and I figure out what's happening for number one. Because what we just did is we did our first piece for selecting for X conjugates by including arginine. Now we have to go back in and see how that changes our options for killing the other bacteria. So we decided to include arginine. So that means we can't kill F minus this way. We can't exclude arginine because we decided to include it. And that leaves us only one option left in order to kill F minus, which is not to put in methionine. So something we can't do, not in media, we can't have methionine. Because if we did, then our F minus would live. So we can only include one of these, and we chose arginine because most of the X conjugates are going to be arg minus. Whereas in terms of met, there's going to be a higher number that are positive versus negative. So we're going to include arginine instead. So we're going to not include methionine, which means that we will accomplish killing F minus. And now we can move on. So we started here, now let's go down to the next gene. We still want to kill the bacteria first. We want to kill HFR and F minus first, and then select for X conjugates afterwards. So we finished this gene, now we're going to go down to STR. STR is also inherited later, and so we're still going to have more X conjugates having the F minus genotype. Okay? There'll be some that are HFR, though sometimes it'll come over, but still it's one of the later ones, so it's not going to come over that often, and then we still have to recombine. So more likely than not, similar to what we said, more likely than not, a lot of X conjugates are strR, because that's our F minus genotype. Not all of them, but a lot of them, and this is inherited more often than arginine, so the proportion should be larger than those that have ARG+. But ultimately, so it's strR, so it's resistant. So we can go and say, okay, should we include it or not? Well, if we go over to how we have to kill HFR, STR, if we include it, would kill HFR, and most of our X conjugates are resistant, so yeah, we're going to include it. We want to include this so that we can kill HFR. STR, I don't know how to spell the whole word, streptomycin. So we want to include it so that we can kill HFR, and also it's the next gene down that's going to be most similar to F minus, so it's going to be the one that kills the least number of X conjugates. So we want to include it in there. And now that we found a way to kill both of these bacteria, we can now select for X conjugates. So we can go down the rest of the way and say what's going to happen with the rest of the genes and what can we do to maximize the number of X conjugates that we get. So here when we look at lysine, let me just add strR, but there are going to be some S, but very small. When we go down to lysine, now we're having more of HFR DNA come over in regards to lysine. So now we have a plus or a minus here, but still, it's still further away, so we still expect more to be F minus, more X conjugates to have the genotype of F minus, but ultimately there are still a good number of them that are HFR. So let's just write off to the side that there's a good number of them, so a large plus sign, that are going to be lys plus because that is the genotype of F minus, and then we're still going to have some, but not nearly as many, have HFR. And so if you need to put numbers to this, just choose something. We know it'll be more likely than not F minus, so let's say that's like 75% of them are this and 25% of them are this. So our X conjugate, 75% can make lysine on their own, and then 25% can't. So this is where a lot of people were getting confused. We already killed HFR and F minus, so now we just need as many X conjugates as we can. So we're going to add lysine because we want to save this 25%. This 75% are going to be fine. But if we want the most X conjugates, we want lysine on the plate. So we're going to add lysine. Okay, we added lysine. We're going to go over here and make sure that that didn't change anything, because we always need to make sure that what we're adding isn't going to allow one of the HFRs or F minuses to live. Okay, now if we go to lac, they could be plus or minus lac, because it could be either HFR or F minus. So should we include it? No, we shouldn't include it, because ultimately if they can be plus or minus, then okay, why don't we just add glucose? So ignore the sugar right now. It doesn't matter because we can just add glucose. They can always use glucose, so why add extra resources? So exclude lactose, and then the same thing actually for galactose. They can use glucose, so why add something else to the media? So we're not going to add lactose. Now let's go to methionine. They're going to be plus and minus here because we're going to have, most likely we're going to have HFR DNA come over and have the chance to recombine. But why won't we? We're not going to add it because if we did, F- would live. Remember, we said not in media is methionine. So we can't add methionine either. We can't do that. So we're not going to. So then we go up to eryR. And eryR could also be S or R in the Exconjugates because HFR came over and it could be either one. So if we want the most Exconjugates to live, don't plate it so that we can accommodate the ones that are sensitive. So all you're going to include in your media is arginine, streptomycin, and lysine. And you aren't going to include methionine. So this is the end result. And let me just go through again what my steps for logic were so that you can hopefully do this on your own. So first, I just wrote out what the differences were between my antibiotics, amino acids, and sugars. Then I went through the different genotypes of HFR and F- and wrote down all of the ways that I could kill either one of these. Then I started going to the actual circle, and I looked at the genes that were inherited at the last time point. So the ones that would be the least likely to be inherited and recombine in the Exconjugate. So we started with arginine, and then we worked our way down the circle like this. I stopped at every gene, and I looked to see what should I do in order to allow the most Exconjugates and to kill these bacteria. Our first goal is to kill HFR and F-, so I'm going to do that with the first two genes that I can. We decide that we need to plate arginine because most of them are going to be eryR-. Most Exconjugates are going to be eryR-, so we need that in order for them to live. So we put arginine in. We went down and we said, okay, STR, a lot of them are going to be resistant because it's one of the later ones to be inherited. And if we use it, we'll kill HFR. So we said, yeah, let's include it. We'll kill the least number of Exconjugates while killing HFR. And then we went down and said, well, they're going to be plus or minus for lysine. Let's include it so that we can accommodate the ones that don't have it. And so that's how we went through the logic for all of these. We went through and figured out